So I was working through these problems that you guys have to do, and I realized that this is very, very confusing. So you can either work through it this way. So let me show you how I did this. So if they're asking me to draw barium and oxygen into a compound, but I don't really know how many barium I need and I don't really know how many oxygen I need, you can draw the Lewis dot structure for each one. So barium is in group 2, so right here. So it has 2 valence electrons, so 1, 2. And oxygen is in group 6A, so it has 6 valence electrons, so 1, 2, 3, 4, 5, 6. When atoms react with each other, you are always going to have the metal giving the non-metal the electron. So barium is going to give this electron to oxygen here, metal to non-metal, and then this electron is going to be given to oxygen here. So then, once it does that, oxygen will have 1, 2, 3, 4, 5, 6, 7, 8 electrons, and barium will also be happy because it is transferring oxygen's electrons. So the formula for this, since you only need 1 barium and 1 oxygen to make this work and make both of them happy, the formula would be barium oxide, just 1 of each. So I realize that this is very confusing. A little shortcut trick that you can do for this is, let's look at barium and oxygen in the periodic table. Barium is, let me see if I can zoom out a little bit so you can look at the whole periodic table. There it goes. So barium is 1 spot and 2 spots away from being a perfect noble gas, which is where all atoms want to be. So let me do this again. 1, 2 away. So barium is 1, 2 spots away from being perfect. Oxygen is 1, 2 spots away from being perfect. Each of them have 2 spots to be perfect, so 2 and 2 will cancel out into barium 2 and oxygen 2. Both of these numbers will cancel out into just being, just being 1. So barium oxide. A more clear example of this is when you actually have like a different number of atoms for each one. So for example, when you have sodium and nitrogen. Sodium and nitrogen. So sodium and nitrogen on the periodic table. Sodium is right here. Sodium is 1 spot away from being a noble gas. So sodium is 1 spot away from being a noble gas. And nitrogen is 1, 2, 3 spots away from being a noble gas. What they're going to do is they're going to transfer their electrons. So the 3 goes to my sodium and the 1 goes to my nitrogen, which is the same thing as like not writing anything here. So the formula for these two when they bond is going to be this, which is what you would have gotten if you would have drawn out the whole thing. Let's do another one. So let's see. Let's do magnesium and phosphate, which is what they were having you do. Magnesium and phosphate. So on the periodic table, magnesium is 1, 2 spots away from a noble gas. 2 spots away. Phosphate is 1, 2, 3 spots away from being a noble gas. They are going to switch their electrons that they need. So magnesium is going to end up with 3. Phosphate is going to end up with 2. So my final formula is going to be magnesium 3, phosphate 2, which is what you would have gotten if you would have drawn it out. Let's do one more, number 3, with aluminum and oxygen. So aluminum and oxygen. Aluminum is 1, 2, 3 spots away from being a noble gas. Oxygen is 1, 2 spots away from being a noble gas. So they are going to switch their electrons because it is a metal and a non-metal. Aluminum is going to have 2, oxygen is going to have 3. So when you write this formula, it's going to be aluminum 2, oxygen 3, which is what you would have gotten if you would have actually like drawn out all of it. So hopefully this teaches you a little skill slash shortcut to use.